Hi, everybody. This is John Wilbanks. I'm sorry I can't be with you at the event today, but I am actually out on the west coast of the United States. It's an honor to be part of this. I've been a fan of the organizers for a very long time, so I'm going to go ahead and just dive in. I've been working in open science for a long time at this point, and one of the things that I would like to start by talking about is how, in a lot of ways, open science manifests a lot of the ways that open can be an ideology, which is to say that it's something that's kind of hard to question or critique or really probe, and that in a lot of ways is kind of constrained and orthodox. But I like to start with, at least in the United States, where a lot of this comes from. This is a guy, Vannevar Bush. He's very well known in the U.S. for two things. One is he sort of envisioned the internet in the mid 1940s, long before it existed. This idea of something called the Memex. But more importantly, in the United States at least, is that he really articulated the argument for post World War II American science policy. Which I think is sort of, I'm going to try to argue, leads inevitably to kind of the open science movement we've got today. And his argument was for this very specific concept of a neutral, rational science that was evidence-based, where the government used taxpayer dollars to invest in science that was kind of pure and academic at research institutions, and that it would be translated through to benefit for the public through corporations. And he really set up the architecture for this. Now, this was political, right? All science is political. So this is a great book, Freedom's Laboratory by Audra Wolfe. And what she really points out is the degree to which rational, neutral science was a political counterweight to Lysenko in the Soviet Union. So even this early stage of neutral, rational science was in its own way political. And I think that ties through to some of the political elements of open science today. But in a lot of ways, if you sort of look at this, what was the outcome of the Vannevar Bush model? It was lots of papers. At the same time that you're seeing this explosion in funding for research institutions in the United States, you see explosions in papers. And this was one thing when we were actually printing them in journals, but it was pretty much another thing over the last 20 years as we started to radically accelerate the publication rate. And radically deconstruct the publishing model towards a digital one. And what you wind up with is something from a knowledge perspective that is what we would call massive incrementalism. This is a process where you encourage everyone to write smaller and smaller grants that are more and more likely to result in some kind of finding, even if it's a tiny one. And what you get as you increase funding is more and more tiny grants going to more and more tiny papers. And then, of course, as we move to the digital systems, those papers are locked up as PDFs. So we're taking knowledge that's fundamentally connected about biology. We're separating it into these tiny little increments, and then we're massively repeating the increments over and over and over again. And this is just a consequence of the way that funding is allocated. Over time, research institutions, how they've evolved, optimize themselves to capture that funding over time, and so forth. It's not something that any one individual did. It's a systemic and structural problem. And you can even start to analyze, like, how much do we get in the United States for $100,000 of research funding? You'll get somewhere between a half a paper and 5 papers, depending on the field you're looking at, depending on how you measure the funding per publication, whether you take an indirect or direct cost, that sort of thing. But you really start to get a sense of the scale of it as you look at the number of total citations in Medline over time, where you have something like 800,000 citations a year plus being added. No one can read this stuff. And so what you create is the massive incrementalism published into these systems makes it really, really hard to connect and figure out causal relationships between biological claims. And so you start to have to reconstruct things like this slide, which is the biological pathway for Alzheimer's disease. There's an incredible density of information represented by papers behind all of this. And we understand this in a pretty interesting, complex, and directional way. However, we can't seem to treat it. Whatever we do when we put meds in doesn't seem to work. And this is not just Alzheimer's disease. It's true of lots and lots of diseases. And so the pharmaceutical industry will tell you this is why drugs are so expensive. The nonprofit and NGO world will counter that these drugs are way too expensive and that there are lots of other ways to fund them. There are, from the NGO side, there are policy proposals to address this. From the corporate side, there are new ways of technology, starting in the late 90s with microarrays. AI is the big hot one now. Sometimes they're wet labs, sometimes they're computational. But there's always this desire that a magic bullet will come in and make it so that we can either benefit from the massive incrementalism, or that we'll be able to sweep away some of the biological complexity and be able to sort of maintain a very traditional or last 50 years capitalist American approach to the pharmaceutical industry, while continuing to create new products. And open science is in many ways one of the latest magic bullets in this. It represents the hope in a lot of ways, grounded in copyright, that if we simply open up access to the papers, that we can text mine those things and we can reassemble all the knowledge that we've got. We can also have single search engines that connect out to everything and let parents of children who are sick, or people who are sick themselves, or people who are trying to provide care in underprovided areas would be able to access all of these literatures. And that's really the idea of the open access movement. And it's been quite successful in scientific publishing. To be very honest, it has changed a lot of policy in the EU, the United States, in Brazil, and many other countries. It's become really the law of the land. It has slowly overtaken closed access publishing, but it's been quite slow, and it's taken 20 years, if more than that, and it's constantly under danger of capture as the publishing industry keeps trying to shift or adapt its business model to maintain the kind of leverage that they've had, because they have this kind of weird little monopoly that they've been able to exploit for a really long time. And more than that, it makes it kind of obvious the degree to which the metaphors we have for open science, that come mainly from free Libre and open source software, are really constrained by the mental models of copyright. Everyone wants a license that'll fix the problem. And I've been part of this. I'm not critiquing people that aren't me. I've worked on biological materials transfer agreements for a very long time at Science Commons, where I was before my current job. There are very smart people like the folks at Cambia, who developed a patent left license. The Science Commons project I mentioned, we went all the way through building materials transfer agreements. You'll see that the deed we built looks like a Creative Commons deed. And in a lot of ways, we allowed ourselves to be constrained by the copyright metaphor. We didn't think about what does open source or free software actually do? What does it create? And in something like biological materials, you can have a much bigger impact, like the folks at AdGene did, by doing things like maintaining a repository of vectors and mailing them out to anyone that asks for them. Sometimes it's not about the legal tool; it's about a service that you can provide, right? And we've had this long period of open science now to ask ourselves, what does it actually do? And it's safe to say that at least so far, open science in the institutional sense, right, we're still inside Vannevar Bush's world of government grants to research institutions, and it doesn't seem to lead to magic drugs, right? It doesn't make it magically easy to connect the literature. It doesn't magically fix biological complexity. Crowdsourcing doesn't seem to magically, by orders of magnitude, increase the analytics. So what does open science do? And what we've seen at my org, Sage Bionetworks, is that it really is epistemological, what open science does in the institutional sense. And so in a more, in the absence of the kind of intervention that open science can provide, you might get these 4 papers, each of which proposes a colorectal cancer subtype, molecular subtype. But each of them are different because each of them has a small subset of data. Each of them has a different algorithm that they've built. And so what you get is 4 different papers claiming 4 different subtypes for the same disease. And in the traditional academic world, it would maybe take them a decade where they would, trade back and forth in journals, letters to the editor, conference papers. And eventually, as the knowledge aggregated out of each of them, we might get a review paper that analyzed across all of these and said, well, here's the consensus. And it's a decade-long process of knowledge construction that has real clinical impacts for people who've got colorectal cancer. And so, if you were to draw it out, right, you might even have 6 different groups because they have different mixes of people in their sample coming up with 6 different subtypes. And so the idea we have is, having to live with the incentives of the all of the scientists. We say, each group gets to add everyone's data together and run their method against it to generate a subtype. But at the same time, at the end of this, we will generate a consensus subtype out of all of them that we can then publish and make available as an open access paper, as an open access model, distribute the code, distribute some as the underlying data. Right? These are ways in which you can short circuit the publishing process of getting to this kind of consensus. And this is not trivial from an epistemological perspective, but it's not as if this is going to change the life of a person who's dying of colorectal cancer right now. This is going to be the theme of open science, is that what it's doing is making an incredibly inefficient knowledge system more efficient, at least in the life sciences for now. Another thing that you can start to do is to triangulate. One of the reasons we've lost a lot of money and a lot of time and a lot of people in Alzheimer's disease over the years is because we've been chasing a hypothesis that turns out to be wrong, a biological hypothesis that turns out to be wrong. And so by trying to see if we give different groups grants to look for the same thing in different ways, so one group maybe uses technological or computational means, one group uses systems biology, one group uses proteomics, and we see what hypotheses emerge in the same labs using different methods, in different labs using different methods. Because if the same gene or the same protein turns up coming from multiple sources, we can have more confidence in that than we might in something that only shows up in one. And you start to see this now after a decade of sort of sustained investment in open science in the United States. You start to see this capacity to triangulate to better scientific investment bets from the government perspective. But again, this is still a long way away. These are things that make it easier to find a drug, which then still has to be tested, developed, run through clinic. You're looking at a decade, if any of this is actually relevant. But it may have prevented a 15-year dead alley. And so this is where you start to see open science having an impact in the institution, right? Doing things like saying algorithmically, can we benchmark instead of peer review? And these are not, unimportant. This is money coming out of people's taxes. This is not trivial, but it doesn't really start to contemplate this concept of really going far beyond the traditional sciences. This would be going outside of Vannevar Bush's world, and that's where I think some of the most interesting stuff is going to happen. And this is not a space that I work in. These are sort of some conjectures that I'm making. But for me, it started when I was working with this group, the Open Source Pharma Group, as they were starting to think about, right, how do we take the open source software model and translate that over to the pharmaceutical industry? Can we actually really think about getting a compound out into the market without any intellectual property at all? Because what's really hard to do with these sorts of chemical materials is to get a patent and then open it. The entire pharma model has from the beginning really argued that you have to have aggressive patents if you're going to have a compound that you can hope to get through a clinical trial and get onto the market. So the Open Source Pharma Group has really been thinking, what happens if you can take a drug that's fallen out of patent? Which they've done at looking at repurposing drugs that might have been abandoned. There's been an interesting batch of drugs that were entirely abandoned by a large pharmaceutical company that over time got funded through a series of grants into a malaria box that any lab working on malaria around the world could order promising lead compounds and then develop them. And this almost looks like an open source methods of production, in the same way that open source software represents that breakdown of the methods of production, where you're one lab in one place for one reason, taking the compounds forward, and then another lab in another place picking up those leads elsewhere. Which is really fundamentally interesting because it represents a way that you might see drugs make it through the traditional pathway with a completely non-traditional discovery structure. So once I started seeing things that way, it struck me that as you really let go of the floss mental model of copyright, there's a lot of stuff that starts to become not just possible, but more likely to have impact in the shorter term. shortly after this, I find the Open Insulin Project and some of the biohacker communities. Open Insulin is fascinating. The first part of what I heard about them was about how they were sequencing all of the genomes in kombucha, and then it was sort of like, oh yeah, and we're also brewing insulin so that it can be priced appropriately, which is free. And it really blew me away, thinking that this is a radical concept. They're not worried about a license or a set of freedoms that a working group defined. They're just thinking, well, if insulin's hard to get, maybe we can just let people brew it, because it turns out it's not that different than brewing other things. That's to me mentally, far beyond the floss concept of open source, which is kind of rigid and connected to copying of creative works, not to the sort of more radical provision of goods, right, or provision of goods and services. And around this, you have just this mechanical revolution. So I love this company, Opentrons. They have amazing little robots, and these robots are not they're not free. They cost a couple $1,000s, but they can sit on a kitchen counter and replicate large quantities of other industrial pipetting robots, and they come preloaded with open source protocols, which lets you sort of out of the box run these things. And so they're not entirely like a Turing machine for the laboratory, but they can replicate a lot of the things that the laboratory required a lot of people and a lot of equipment to do, and they fit in your kitchen. And if you sort of play this out into the future, and you say, well, what happens when you can start to do molecular 3D printing, where you just have to download the CAD file of a compound, whether that compound is on patent or off patent, and just print it. And you start to even see this showing up in speculative fiction. It's in Gibson's latest novel. It's in Annalee Newitz's novel. There's this. It's pretty clear that this is where things are going, and so it starts to look a little bit like maybe the Homebrew Computer Club in the late '70s in Silicon Valley, where you've got this, the small group of people who are the first ones to realize that all the gear is cheap enough that they can hook it together and do stuff. And I think in a lot of ways the bleeding edge of this is sort of the actual open science movement out on the edge beyond what we do. The people who are outside of Vannevar Bush's world, who are outside the models of copyright. And one of the questions that gets asked of us a lot, and that we encourage people to ask, is, out of all this, how much money's going in and how many users are there? Because when there's lots of users and not much money, open movements are pretty easy to sustain. When the money starts to overtake the users, it can get harder. That's when you start to get conflict between principles and operations, and the tendency is to sort of break the two apart. And I think that there's an analog to this in open science that we don't talk enough about, which is ethics. We have this concept of the official future, which Nils Gilman here has written about. I encourage you to read. But this idea of the official future is that, at least in the West, it's an organizing set of principles. They're not true, right? But they're lies we tell ourselves to sort of knit society together towards a goal. And we have had this kind of techno-liberalism in the United States and in a lot of Europe and a lot of the rest of the world that was the official future, right? It was technocratic. There weren't going to be a lot of any big changes, and technology was more or less good. And a lot of, again, these mental models of open, I think, emerged during that official future, and now we don't really have that. Whether it's the stuff that's happening politically, or more specifically, technologically, the understanding of the vulnerabilities of these open systems that we've built. And sometimes it's going to be truly open systems. If you think about the repurposing of Creative Commons photographs as a biased data set for machine learning and facial recognition, whether you think about the way that gigantic companies run on top of open source software, but don't do anything from a remotely open source perspective, through to the biases in AI and training models, right? There's any number of vulnerabilities that have been baked into the socio-technical systems that we depend on. And as we think about open science, right, there's a really sort of fun story to tell about all the innovation and user innovation and break-ins into the price system that I think are important stories and true stories. But at the same time, and I assume other people will tell those, and I'm glad for that. but I would want to remind us that we always have to think about the vulnerabilities of these systems. Because to me, one of the big lessons of the last 15 years is the degree to which vulnerable systems that can be attacked, as soon as they are valuable enough to be attacked, will be attacked. And some of the attack is sort of easy to see, right? Capital has an impact on all of this, and so there's a lot of money going into all of this, and obviously that can take relatively predictable ways where it can change things. You know, we like to talk about just trolls, but trolls in biospace have a pretty different threat profile. They're probably less likely to achieve their goal, right? It's much easier to distribute a shitty computer virus than it is to distribute a shitty biovirus. But we should expect trolls to be a part of the landscape, and we should be saying at least, what are the sorts of things we can do that make it less attractive to be a troll here? It's one of the things I would think from a design perspective we all have an obligation to think about is not just happens when we do this stuff as good people, but what happens when terrible people use this stuff. And some may do it because they're trolls, but you know, um, this is one of my favorite misattributed quotes, which is this: "Never doubt a small group of committed citizens could change the world." But what if that group is evil and wants to kill people? Because all of the systems we can use to make these things are going to be able to be repurposed. And if our technological systems are repurposed as part of just what we structure, and then what kinds of things can we do inside this movement if we're not constrained by the floss movement, to think about dealing with this threat model, right? And it doesn't require quitting, it doesn't require stopping. Um, but it does, I think, give us some chances to think about what are the pieces of ethics we might bring forward that might help us. And so the sort of classic document in the United States is the Belmont Report, which came out sort of after Tuskegee and a bunch of human rights violations involving biomedical research by the United States government, and identified these three key principles. And I love them because to me they're like the four freedoms in software. They're guideposts. And the three concepts are respect for persons, beneficence, right, good doing, and justice. And those are great principles to ask ourselves, how can we integrate these into these? And so as we think about radically open science, independent review, institutional review boards, this is sort of the way that Vannevar Bush's system deals with it. And I'm not really proposing that for this community, and I think if I did, no one would listen. But I think the idea of independent review, right, having someone who understands what you're doing, who's not you, right, ideally who has a diverse viewpoint from you, and having them check what you're doing before you do it, right, that diversity of thought, that kind of check-in, that has a lot of scientific value. That has a lot of value to the people who are participating in that radically open experiment. Um, and I encourage, thinking about this. This is something that really occupies me, which is how do you get that independent review, right, when you're fundamentally not working in an institutional context? Because it's got to be possible. And building in respect for persons and beneficence and justice, strikes me as something that's fundamentally worth doing. Because those things are often absent from the daily practice of research as people know it. And then on top of that, right, this is the fundamental question: is if ethics were integrated with the kind of radical acceleration of science that this open science beyond the institution can do, is the ethics part of the immune system? And I would argue that we should at least contemplate that all of the frictionlessness of the internet and social media systems made it easier to capture them at scale because it was easier to roll it all up. And having some form of this integrated open ethics that is culturally appropriate, locally appropriate, it might slow things down a little bit, but that slowdown, that moment of thought, may also be something that helps aid against capture by the various systems that are to come and try to capture it as soon as it becomes valuable. So that's what I wanted to say. I appreciate you listening. I'm sorry I'm not there in person. And thanks again for the invitation to be part of this.